This is the Unit 5 Lesson 5 retrieval in our packet. It's on page 38. Okay, for number 1 and 2, we're supposed to rewrite the equations so that they are in slope-intercept form, which they helpfully remind us is y equals mx plus b. So basically, we're just rearranging this to get the y by itself. Okay, if I want the y by itself, first I need to get rid of the x. If this was just minus 6 with no x, I would add 6 to get rid of it. So I'm going to do the same thing here. I'm going to add 6x to get rid of it. Now, I cannot combine these because they're not like terms, so I just have to write them next to each other. So this went away. Now I have 2y equals. Now I could write 12 plus 6x, but I'm trying to make it look like this. So I'm actually going to write 6x plus 12. Just so that it more closely matches this slope-intercept form. Now the last thing I have to do is I have to divide by 2 to get the y totally by itself, and I have to divide this entire side by 2. That leaves me with y equals, now I'm going to look at these one at a time. 6x divided by 2 is 3x. 12 divided by 2 is 6. So there is my slope-intercept form for number 1. Okay, let's do another one of those. Once again, trying to get the y by itself, I'm going to start by subtracting the x value. Since this time the x is positive, I need to subtract to get rid of it. In the last one, it was negative, so I had to add to get rid of it. All right, so now I have negative 5y equals, I cannot combine these, so I'm going to write negative 3x plus 20. Okay, now I have to divide to get the y totally by itself. So divide by negative 5. Okay, now you might notice that these two numbers don't really simplify nicely like in the last one, so I'm just going to write them as a fraction. I could write negative 3 over negative 5, but we know that negative divided by negative is positive, so I'm going to write it as 3 over 5. And then there's an x. Now these two numbers do simplify. 20 divided by negative 5 is negative 4. So if you can simplify one of them but not the other, that's fine. Just leave one of them as a fraction. Okay, now we have to do the reverse. We have the equation in slope-intercept and we need to write it in standard form, which is where we have the x and y on the same side of the equation. So I think I'm going to subtract 4x from both sides here so that I can get the x and y on the same side. Like that. And technically in standard form, the x value is supposed to be positive. So technically, the last thing I should do here is multiply everything by negative 1, which would make this 4x minus y equals negative 7. It's kind of a picky rule about standard form, but the x value is always supposed to be positive and a whole number. Okay, we're going to skip number 4 for now and go down to number 5. We're supposed to solve the system of equations by substitution. So if I take this first equation here, I can write it all out, but I can replace this y with this stuff. Since they both equal y, I'm basically just setting them equal to each other. Okay, I've got x's on both sides, so I'm going to get rid of the smaller one. I'm going to subtract 23x. That'd be 4x plus 6 equals, that goes away, negative 30. Now I need to subtract 6 from both sides because I'm trying to get the x by itself. Negative 36. Oh, I actually have enough room to do the problem. What do you know? Divide by 4, x is negative 9. Now that is not my entire solution because I need x and y. Anytime you're solving a system, you need to have the x and the y value in your answer. So now what I would need to do is take that negative 9 and plug it into either equation. I'm just going to go with the second one. And I'm not doing that in my head. Negative 243 plus 6, negative 237. So your final answer would be negative 9, negative 237. Why does that seem wrong? I'm a little suspicious, so I'm just going to quick plug this in. 23 times negative 9 is, okay, minus 30. Minus 30, come on. Negative 237. Oh, well, there you go. So you can always check your answer by plugging in the x and the y, especially if you're a little suspicious. Okay, cool.